Hello everybody, it's Grasshopper tutorial for the University of Queensland School of Architecture, Christina here, and in this tutorial we will see how Boolean Dispatch tool works, and we will start with creating an object. I think we should start with a sphere, so we will create a sphere straight in Grasshopper, no need to do it in Rhino for now. So let's create a sphere. Here it is, the sphere. Let's give this sphere some sort of radius because I want it to be probably 10. Yep, that works for me. Next step will be to populate this sphere with points so that we will have its surface as a network of points. There is a special tool for it, it's called Populate Geometry. Here it is, Populate Geometry. And we're using sphere as the geometry we want to populate, and as you can see, with this tool we created a number of points unevenly, well actually more or less evenly but without any special order, populating our geometry, which is a sphere here. We can get some sort of count to that and decide that we want 100 points. Less, more, it will all define where they are. Less points, more points, up to you, and depends on what do you actually want. Then seed is it's kind of randomizer, and it will define where are your points on the sphere and propose different patterns of this dots. It's going to be still random, but let's say some random number and see how it goes. It changed, but basically the same number of points, just different options of it, like shuffle play in a player. Picks different things but following the same rules, more or less. Now I want to deconstruct the location of each point and extract the coordinates from it. So deconstruct point. Where is it? Deconstruct point. Here it is. We're feeding here points, and we will have x, y, and z as outcome, which we will use. Now I will, as you can see, my sphere now is in the center of the sphere is on the 0 in the beginning of coordinates, where these two axes x and y intersect, which means it's also where z is, 0 of z, so z positive is the upper part of my sphere, let's say here, while z negative is here. And I'm gonna use it to play with my sphere and see how it's gonna work out. To do that, I will need to introduce math component, which is called larger than. So we will operate numbers larger or smaller than 0 here. I picked z-axis because it's more visual, because we have this plane as 0, so it's going to be my first number. And second number will be 0, which I can specify as slider or as a panel or as whatever I actually like. Here we go. And I have two outcomes, larger than or larger or equal to. I will use larger than in my case. Let's see what do I have as the outcome. Number of points that are either larger or smaller and equal to 0 on z-axis. So what I'm going to do now is use dispatch and use my population population is here. Here it is as a list. And I will dispatch this amount of points. So I will have list A and list B as the outcome here. And to visualize it, because this component just contains the result but we can't see it, I will create spheres and boxes. Actually, I want a special box with a center. Where is it? Not here, here. Okay, I wanted it to be center box actually, to be honest. Using points as the base. And here we go. I have spheres on all points that are higher than 0 on z-axis, so exactly 1/2 of my sphere, and boxes that are lower than 0. If I had a point, location of object 0, 0, 0, I have a point here, and if I introduce it to grasshopper and set one point, this is the point, and if this point was the base of my sphere, I could actually use it to manipulate my sphere. And if I pull it a little bit up, then you can see that now 0 of z-axis is lower, so I have less boxes and more spheres. If I do drag it here, I'll have the opposite. So you can see where 0 is, more or less. Another exercise based on this one, exactly from this part actually, we'll do a little bit different thing. We will use more coordinates. Let me show you how it's gonna work. Let's for now hide this. Okay, here we go. Here is our deconstruct component, and we will introduce this mathematical equation, which is larger than, to all three outcome elements. Let's just copy it. Let's feed the location of x, y, and z components as first number to all three of them. And we can actually use 0 set as, why didn't create I have it? I can just Ctrl+C, Ctrl+V it, and plug it as the second number here, using just one panel for all of my components, because why would I bother to create 3 of them if I want 0 for all of them? Next step is the new component we haven't used yet. It will kind of combine what we have here, and it's called gate end. Let's type it here. Oops, why do I have caps lock? Gate end, not really end. Here it is. Gate end, what we'll do, let's ask it, perform Boolean conjunction. And I want to perform it to these 3 outcomes. A, B, and we can insert another port here, clicking on plus button under the last letter here, so B plus C. Now we have C, and we can easily plug it here. Now we have all 3 of our components in this element. And from here we can go with dispatch we used earlier. Dispatch. Just if you get confused, it's located under sets, list dispatch. And let's try it out here, so that we have two lists as the outcome, and we will introduce the same idea with spheres and boxes, I believe. Why not? In here, A here and B here. Why not? Should be working. AB, dispatch. What could possibly go wrong? I could have plugged it into wrong port. Okay, now it works. Almost. Oh, of course. Sorry. It happens. I forgot to put the main thing here. It's our population. Now it works. Let's switch it all on and make it all visible. So you can see that Grasshopper took only points as spheres, only those that are actually as the other ones. Only those that are located more than 0 from coordinates, from the beginning of coordinates. So it left just quarter of the other outcome, which is here. Makes sense? Let's make it funnier and put some colors here using custom preview. Swatch, color swatch. Let's say white. So all larger than 0 on all coordinates is now populated with boxes, and all that is not a part of, actually with spheres, sorry, and everything that is not part of this kind of equation is different. That's how you can take any portion of your geometry and manipulate it separately. I hope this will be somehow helpful for you, and thanks for your attention.